Alright, man, hope you enjoyed yesterday's video. Today we're going to move on to section 8.3, talking about special right triangles. The first one we're going to talk about is a 45-45-90 right triangle. But if you look over here to the right, this 45-45-90 right triangle comes from a square. So if we were to draw in one diagonal in a square, we get an isosceles right triangle right here. We know the legs are congruent. Therefore, if the legs are congruent, we know that the angles opposite those legs are congruent. So the base angles are congruent. So that means that each measure of that acute angle will be 45 degrees. Why is that? We know that this is 90 degrees. All triangles add up to 180. So these two angles are 45 degrees. And this is what we call a 45-45-90 right triangle. We can prove theorem 8.8 using the Pythagorean theorem. If you look at this triangle that I have right here, I've got a leg, and a hypotenuse. I'm going to abbreviate the leg as the variable L. So both those legs are going to be L, and the hypotenuse will be H. I'm going to use the Pythagorean theorem to solve for the variable H. So if you look over here, you'll see that I start off with L squared plus L squared equals H squared, and that's because of the Pythagorean theorem. Well, L squared plus L squared becomes 2L squared. That is equal to H squared. That's just combining the like terms. Now, like I said, I want to solve for the variable H. So we have to take the square root of both sides. And when I simplify this, and I'm not worried about the algebra right now, we get that the hypotenuse is equal to the leg's length times the square root of 2. So that leads me to the 45-45-90 triangle theorem. It says in a 45-45-90 right triangle, the legs are congruent, and the hypotenuse H is the square root of 2 times the length of a leg. So if I have a leg and a leg, then the hypotenuse is leg times the square root of 2. Looking at example number 1, it says to find the value of x. Well, if I'm looking at this bad boy, I see that this angle right here is 45 degrees. So that means that this angle right here is also 45 degrees. So now I know I have a 45-45-90 right triangle. The formula states that if I want to know what is the value of x, x is the hypotenuse. So the formula says that the hypotenuse is equal to the length of the leg times the square root of 2. Well, I know I've got a lot of variables here, but just replace h with the variable x. So x is equal to the leg's length times the square root of 2. And in this problem, I see that the leg, L, in this problem equals 9. So that means the hypotenuse, x, is equal to 9 times the square root of 2. And all that is substitution. Again, looking at example 2, I see that both these legs are the same length. They're 6 square roots of 2. So I have to find the value of x, the hypotenuse. And previously we mentioned that the hypotenuse is equal to the leg's length times the square root of 2. So in this problem, I'm going to replace the hypotenuse with its variable. In this situation is x. So x is equal to a leg's length times the square root of 2. Well, in this problem, L is equal to 6 square roots of 2. So we have some multiplication going on, just like a substitution. So that means wherever I see an L, I'm going to replace it with 6 square roots of 2. So I've got that x is equal to, and I'm going to change the font color. Maybe I should do it this way. That's 6 square roots of 2. So that means 6 square roots of 2 times the square root of 2. Now that's the formula. In this problem, L is 6 square roots of 2. So the square root of 2 times the square root of 2, you guys will love to say that's the square root of 4. So x is equal to 6 times the square root of 4, but the square root of 4 is really 2. So x is equal to 6 times 2. That means x is equal to 12. So in this problem, x is 12. The hypotenuse is 12. Looking at example number 3, I'm asked to find the value of x again, and x is along my hypotenuse. So that means that the hypotenuse h is equal to, and that is L times the square root of 2. If I look over here, I see that I have a 45-degree angle, so that means this angle also has to be 45. So now I have base angles that are congruent, which means these opposite legs are congruent. So I know in this problem that L is equal to 7. So all I have to do is replace substitution. X is going to be the hypotenuse. So x is equal to 7 times the square root of 2, which we just rewrite as 7 square roots of 2. So the previous 3 examples were dealing with finding the hypotenuse. But we could also work backwards using theorem 8.8 to find the length of the legs of a 45, 45, 90 triangle, given that we know the length of the hypotenuse. So this example, I want you to find the value of A, and A is representing a leg. So we know by the formula that the length of the hypotenuse of a 45, 45, 90 triangle is the square root of 2 times as long as a leg of the triangle. So the hypotenuse is L times the square root of 2. And that is the formula, the triangle 45, 45, 90 triangle theorem. All right. So in our problem, we know that the hypotenuse is 8. So I'm going to plug in 8 for the hypotenuse, and here the leg is the variable a, so I replace a with L. So I have the formula, or the equation here, that 8 is equal to a, the length of a leg, times the square root of 2. Well, if we want to solve for the variable a, we got to get a by itself. So I got step number 2 by substitution. And then I'm going to ask myself, how do I go from 8 equals a square roots of 2 to 8 divided by the square root of 2? And simply, we just divided both sides by the square root of 2. Well, this is where we run into kind of an issue in mathematics. I'm circling it right here. Mathematicians do not like what I have circled when we have this square root of 2 in the denominator. So what we have is this thing called rationalize the denominator, meaning I want to take the square root of 2 away and make it a whole number. So how do we do that? And rationalizing the denominator, we simply multiply the denominator, here in this case, by the square root of 2 over the square root of 2. And when we multiply it by the square root of 2 over the square root of 2, that number is really 1. So I'm not changing the problem, but I'm changing the way that it looks, the way that it appears. So that when I multiply by the square root of 2 over the square root of 2, that's what we call rationalizing the denominator. So 8 times the square root of 2 is 8 square roots of 2, and we know the square root of 2 times the square root of 2 is the square root of 4, which is simply 2. So that was just rationalizing the denominator. Then I multiplied. And lastly, how do I go from 8 square roots of 2 divided by 2 to 4 square roots of 2? I divide by 2. So the leg is really 4 square roots of 2. So in short, how do I rationalize a denominator if I need be? We need to multiply the numerator and denominator by a radical that will get rid of the radical in the denominator. Real simple, if it's a square root, just multiply it by the number underneath the radical. So in the problem over here, I have 5 divided by the square root of 10. Notice that we multiplied the numerator and the denominator by the square root of 10. So I get 5 square roots of 10 over the square root of 100. We know that the square root of 100 is 10, so the square root of 100 is 10. So I get 5 square roots of 10 over 10, which is equal to the square root of 10 over 2, because 5/10 is really 1/2. So that's where it reduces to the square root of 10 over 2. I took it over here. Maybe the numerator won't be able to simplify. So if we look at this example, this is one where we can't simplify because they're both numbers that have no common factors. So if I look and say rationalize 5 divided by the square root of 3, simply multiply by the square root of 3 over the square root of 3. We get 5 square roots of 3 divided by the square root of 3 times the square root of 3. We could think of that as 3. So I have 5 square roots of 3 over 3. If you really want to know just in simplest terms here, men, if I have 5 over the square root of 2, all you have to do is take, just to keep it simple for you, is to move this 2 upstairs. So square roots of 2 goes upstairs, and then all you do is remove the radical. That's the simplest form. That will work for rationalizing square root of 2 in the denominator. So if it was an even number, so for instance, if we had 18 over the square root of 2, I'm going to move the square root of 2 upstairs. So I get 18 square roots of 2, and then just remove the radical downstairs over 2. And now I have to simplify. What is 18 divided by 2? I get 9 square roots of 2. Looking at example number 5, I'm going to start off with my formula for the hypotenuse. So h is equal to L times the square root of 2. And in this problem, we know that h, the hypotenuse, is 6, and the length of the leg is b. So now in order to solve, all we have to do is divide both sides by the square root of 2. So divide by the square root of 2. I get that b is equal to 6 over the square root of 2. Using my nifty needle trick, remember we're going to take and move the square root of 2 upstairs, and then remove the radical 2 downstairs. So now I have to simplify, so I get that 3 square roots of 2 is what b is equal to. Okay, looking at this problem, it was a word problem. I drew the picture. I have a 45, 45, 90 degree right triangle with a hypotenuse of 10. So using my formula, h equals L times the square root of 2, I'm going to go on and divide both sides by the square root of 2. So I can get L by itself. So L is 10 over the square root of 2. Again, I'm going to use the trick. So I get 10 square roots of 2 and remove the radical sign downstairs. So that becomes 5 square roots of 2. Okay, last example. I have h is equal to L squared roots of 2. For the hypotenuse, I see that h is 7, so I replace h with 7 and L with the letter A. So we divide both sides by the square root of 2. So we get that A is equal to 7 over the square root of 2. I have to multiply by the square root of 2 over 2, or using my nifty needle trick, I get 7 square roots of 2 over 2, and I am finished. That is what is A.